All right, so in this video, we are going to solve this problem. You can see that we've got this resistor network here with a voltage across it. It's 40 volts right there. And they've only given us one bit of information about each resistor. Uh, but we have to find the value of each resistor. Notice that they've just given us either the voltage drop across the resistor, uh, the power dissipation of that resistor, or the current through that resistor. So we have to figure out what each resistor is. So let's start. All right, so we notice right off the bat that IT here is 4 amps, and IT is coming from the current source, and it's entering this node. Well, uh, we don't actually know how much current is going this way and how much is going this way. We just know that that's what's happening. So I guess I'll mark that. That's the way that the current is going. So let's see if there's anything that I can identify here. Well, here's something I can identify. I know that if 4 amps left the voltage source right here, then 4 amps must be returning via this path right here. So there must be 4 amps going through this resistor. So I don't yet know what the value of the resistor is, because in order to know what the resistance was, I'd either need to know the power dissipation of this resistor or the voltage across it. So let's see if I can figure out what the voltage is across it. I know that anytime a current is entering a resistor, I put a plus where the current enters and I put a minus where it leaves. Well, I know that there's a plus right here and a minus right there. So if I'm going around the loop like this, tracing that path, anytime I pass through a resistor and it's plus to minus, that means that the voltage has decreased. If I pass through this way and it goes minus to plus, then that means the voltage has increased from this point to this point. So anyway, let's go around this loop. I'll start right here. So I'm using Kirchhoff's voltage law, which basically says the sum of all the voltage increases and decreases around the loop must be 0. So I'll start right here. Well, I just crossed a 40 volt source. So I went from 0 right here to 40 volts. And that was minus to plus, so it's positive 40. So I've increased by 40. And then I'm going to go down here. Notice they've given me that voltage drop. Well, I've decreased by 20, so that means there must be 20 volts across this one, because 20, 20, and 40. See how we increase by 40, we drop by 20, we drop by 20. The sum is 0 when we've gone around the loop once. So I can figure out what this resistor is now. I just use Ohm's law. What is the current through the resistor? It is 4 amps. What is the voltage across the resistor? It is 20 volts. So V divided by I equals R. And so 20 volts divided by 4 amps is 5 ohms. So this is a 5 ohm resistor right here. Okay, well, let's see if there's anything else that I can know here. Can I figure out that one? I don't know the current through this yet. I know the power dissipation of this. Actually, I do know the current through this, because look, they've given us this current, and they've given us this current right here. So we know that by Kirchhoff's current law, that the sum of all the currents entering and leaving a node must be 0. So we know there's 4 amps leaving, and I see 1 amp entering, another amp entering, so we've got 2 amps entering, and that only leaves this path, so we know there is 2 amps of current going through this resistor. Well, 20 volts divided by 2 amps is 10 ohms, so we know the value of R3 now. All right, Well, let's see what else we know. Here's another thing we know. So I was asking what the current split was going through this path and this path. Well, now I know. If there's 4 amps flowing in and 2 amps leaving through this path, that leaves 2 amps leaving through this path right here. So what is uh, the formula that is going to relate amps, power, and resistance? Well, I think I'd like to find the voltage first, because we know that power is current times voltage. So that means that 20 watts equals 2 amps times some voltage. Well, it looks like that voltage would be 10 volts. So there's 10 volts across this resistor. All right. Well, 10 volts divided by 2 amps equals 5 ohms. So now we know R1. Great. So let's continue on here. Do we know the voltage across this resistor? I think we could get it, because if we just go around this loop, the sum of all the voltage increases and decreases should be 0. So plus minus right there. So let's start right here. Let me put my plus and minus. Okay. So I've dropped down by 20, so I'm at negative 20. And then I've dropped down by some other amount here. Am I right? Oh, sorry, made a mistake. I've dropped down by 10 right there. So I'm at negative, I start here, go over to here, I'm at negative 10. And then I drop down by some mystery amount, and then I jump up by 20. So in order for the sum of all these things to be 0, that would mean that there needs to be 10 volts across this thing right here. So we start here, drop down 10, drop down 10, jump up 20. The sum of all those is 0, so that's good. And we know we've got 1 amp going through this path right here. So 10 volts divided by 1 amp is 10 ohms. So now we know R4. All right. Let's see. What else could we know here? Okay, I see that they've given us the voltage drop across R6 and R5. So let me make some polarity marks right there. So the current is going to go like this, and then we've got another current that's going to go like this. And once again, I'll put polarity marks right there and right there. Okay, so let's go around this loop. I'll start right here. So I've jumped up by 5. I've dropped down by some mystery amount, and I've dropped down by 1 volt. So that means there must be 4 volts across this one right here. Well, if there's 4 volts and the power dissipation here is 2 watts, V times I equals power. So that means this. That means 2 watts equals 4 volts times some current. Okay, so it looks like that current would be 0.5 amps. So there's 0.5 amps going through these two resistors right here. 4 volts divided by 0.5 amps equals 8 ohms. So this is an 8 ohm resistor at R2. 1 volt divided by 0.5 amps is 2 ohms. So now we know that one. We know all the voltage drops now. We just need to figure out the current through this resistor. Well, there's 2 amps entering, 1 amp leaving, 0.5 going this way. That leaves 0.5 amps going this way. Okay, so 5 divided by 0.5 is 10 ohms. It's a 10 ohm resistor. And we've just got to figure out this resistor right here. But that's not going to be hard, because we know we've increased by 10 volts. We've dropped down by 5. That means the voltage drop across this must be 5 volts. 5 volts divided by 1 amp is 5 ohms. And we have done it. We have figured out the value of each resistor. So we basically used Ohm's law, Watt's law, Kirchhoff's current law, or Kirchhoff's voltage law, and Kirchhoff's current law. That's how we solved that problem. And that is it for this one.